Okay, now question A4 is asking you to write the code for the method remove using representation which you explained in question A3. So how can we remove a cell from a linked list which turns into the representation of the array list? If we go to the notes, we've got how to remove cells from a linked list. But remember, the linked list is inside an array object. Well, here's how to add a cell, and here's the next how to remove a cell. Pointer next is pointer next removes a cell. So we need to do this inside the array object. This is how we remove a cell. We need to have a pointer to the previous cell, and we cut out the link. Okay. Now, the only thing we need to be aware of, if it's the first one that we're removing, we need a special code to deal with that because we don't have a cell before it to do it. All this is explained in the notes, more or less just to, here's the method remove, which is in the notes. But I wouldn't suggest memorising this code here. That's not the way to deal with this sort of problem. Look at the diagrams. See how they're working, and if you understand this, you should be able to write the code that does it without having memorised the code. If you were to try and memorise this code without really understanding, it's a tough job. There's a lot of things to memorise. Memorising things that you don't understand is a very, very difficult task. Writing code, once you've got used to code and you're confident handling code, you use it. It's like learning another human language. You need to become confident by practice, and then it comes naturally. Writing code to do the task that you need should become natural, and as I said, that's best done by practice, practice, practice. If you practice reproducing this code, from knowing the algorithm that it's doing, should be easy. You don't need to memorise the code, you can know what to do when you want this code. Okay, so I think I probably just need to say this is the code that does it. Write this code, but not by memorising code, by thinking through what this code actually does. Okay, so now let's think how we would tackle the actual code writing aspect of this problem. But let's remember the structure that we're in. We're writing this inside a class array, my array list, and it's got its own field cell. So the method remove has to manipulate this field to cause the effect of removal. So from 10, 20, 30, 40, we want to remove the object in the list which is at a particular position. Position 0, 1, 2, 3. Remember in Java counting always starts at 0, not at 1. So if this is a representation of the array list, sort of thing we've got. We've got an array list object with a cell object inside it. Now, removing the object at position 2, 0, 1, 2 would be removing the 30. We're going to generalise from this to a general example. As we saw in the notes, we're having a pointer to the cell before, and then doing a next, shifting that pointer to the next and cutting out that link. Okay. So, Well, in this case, there's no marks for getting the header right because you're given it, but you have to write the code which carries on, implements this. I said there's a special case if we're removing the first element, so the cell becomes equal to cell next. So that's if I is 0. Forgotten something here because I've got a return type, which the element that's removed is returned, so I should return that cell. So actually, I'm going to have to change that. Because I need the value of the first in the cell. Okay, so you can see how I'm thinking on my feet here. I started off writing that, I realised I got it wrong, had to alter it again. Don't be afraid to do that when writing code behind it in an exam. You may need to sketch it and then write it again full. If it starts to be a bit messy, you need to think it through. Maybe even as you can see, even I don't always get it right first time round, but I have to think about it and manipulate that code until I get it right. Now, that's the case where we're removing the first item. Now we want to remove a later item, so else, and then we'll carry on with how to remove an item which is later in the list. Now let's consider we want to remove the element of position 0, 1, 2. We need a pointer pointed to the one before it. We want to get up to position 2, so how many times do we need to change it? One less than I think. J. Okay, so this should move the pointer down a number of times, one less than decimal. A is 1, we want to remove 1, the pointer will go down 1, no, you see I've got it wrong. I need to start at 1, it needs to point to the one before. Again, the point is, I'm thinking here, I get it wrong, I think about it, I need to crack my code. Okay, now, this will result if I is 2, pointer will go, start of a cell, move down once, because J is 1 and J is less than 2, we'll go down once, okay, and then that will get us pointed to the right place. So now, in our example, pointer moves down the list to here. We return, actually pointed, no, actually pointer. Pointer next stop first, which is pointer. This is pointer next first, which is for 30 we return, and then pointer, no, I've got it wrong again. Pointer next, pointer next, next. Well, okay, so now you've seen I've tried to solve a problem, and being videoed I got a little bit nervous and I got it wrong. But I had to think through, is this code right? Look at my diagram, relate the code to the diagram, no it's not quite right, modify my code and, okay, now I think this is the correct code. Okay, the point here is you see how I think through writing this code. I think through, look at how it works and get it working. I didn't have this code memorised in my head, and so when I started writing it, I didn't get it right the first time round. I think about what it was doing, relate that to the diagram, how I think of it conceptually, and then I got to the right code. That's the correct approach to solving this problem, to writing code. Don't memorise what the code does, think through what the code does, look at the code, think about it conceptually, maybe using diagrams, and make sure from that get the code right. Well, when I looked at my answer, it's correct, but as you see in the video, I almost made a classic mistake myself, corrected it at the last minute. Pointer next first, pointer next is pointer next next. I'm going to just explain this in a little bit more detail because it's a very common misunderstanding, how to change destructively a linked list. Just a very minor thing, remember with loops, if you don't put a curly brackets around it, it's only the first statement inside the loop which is after the loop, which is inside it. So there really should be a curly bracket around here and here. I tend to leave them out if they're not needed, because I think they can clutter code to put them in when it's just one statement. Other experts disagree and say always put them in because it makes it clearer. Either way, I'm not bothered either way, but as Java programmers you should be aware of it can be done without the curly brackets if there's only one statement inside the loop, but you need to be aware of that convention. You can't put two without curly brackets, only if there's one statement. So if anyone was confused by that, just remember what these mean. Okay, now I'm going to just talk a little bit more about this pointer next and pointer next next issue, so I'll blank the screen. Okay, right, so okay, so here we've got the representation of linked list 10, 20, 30, 40, 50. Okay, and let's suppose we want to cut out the 30 from here. The pointer needs to point to the cell before we cut it out, not the cell after. I always made this mistake myself, because I wasn't thinking exactly what I was doing in the answer, but I corrected it. Okay, pointer next, pointer. So this is pointer next. If we set this to pointer next next, the effect is to change this pointer internally, I'm going to rub out, to this one and cut it out there, which is what we want to do. Okay, just to see, why doesn't pointer next, why can't we have pointer here, and why can't we just then say pointer next, pointer equals pointer next? Why won't that work? And it's a common mistake I find by people assuming that this will delete the 30 from this list. It won't work because pointer is just a variable. It's not, if I say pointer is pointer next, it will change the value of this variable. So pointer now becomes into pointer next. It doesn't change the list, it doesn't change the structure. Nothing internal to the structure has been changed. It's This is still 10, 20, 30, 40. If you just change a variable, which is a temporary variable inside a method call, it doesn't have any long-lasting effect. So just to be clear, if you want to change a linked list structure destructively, you must do it through a pointer to an object in it and change the fields inside the object, not by changing the value of the variable itself. A variable points to an object and changes what's inside the object. Common mistake to make. I almost made it myself because I was thinking, rushing through that question because I thought it was an easy one, but this time I corrected it myself and got it right at the end.